Data science, training for finance and risk analysis, a pedagogical approach with integrating online platforms. Welcome, Afshin. Please take the words.
Okay, good morning to all. Let me thank you for having me for this session. My name is Afshin Ashofteh, and I'm here to present a paper entitled Data Science Training for Finance and Risk Analysis, a pedagogical approach with integrating online platform, which is about an experience for teaching data science and statistical learning for finance and risk analysis. So this presentation is structured as follows. First of all, I'd like to give you an overview of this research and motivation. Next, I'll focus on a graphical summary of how data science could be defined for financial risk management. Next, a pedagogical experience to cover most of the necessary steps by combining different technologies and platforms in an integrated manner, and how we combine these online platforms to apply an active learning approach with an online discussion group and a book club. And then we'll consider discussion and conclusions from this experience. What do I propose in this research? I propose a data science training approach for finance and risk analysis, which is based on a published paper and one ongoing research. But here we would avoid theories and how the model was developed, only application. Uh, how was it done? With developing a model and then a combination of different technologies and platform in an integrated manner. So you will see an online QA on the Kaggle competition platform with a programming project for credit scoring, an online book club for presenting chapters of the reference book by students, an online video platform to upload the videos of presentations by students with opportunity, of course, to put comments on their colleagues' videos. So what is the motivation? The motivation was to find a way to deal with the challenges of teaching data science for finance and risk management, which is a multidisciplinary course and cover not only the scientific part but also the necessary soft and hard skills in an active learning process. So my first point concerns the unsuccessful experiences of academia and industry to train good data scientists for finance. In fact, academia is training data scientists, which extremely elegant mathematicians, completely able to describe a word that does not exist. And on the other hand, the industry and business schools train data scientists capable of overfitting their models to their fundamental ideas. And both have problems and doesn't work. In this graph, we see how data science works in general. First, we start with data, but the quality of data is speaking. We use statistics for descriptive analytics to form the information. We use analytics and diagnostic analytics to extract knowledge. And all of these steps are working on historical data. But in finance, the future is important, right? So we continue with machine learning and forecasting models. We make some plans. We present our plans with business intelligence dashboards and competitive analytics. Then we estimate the errors. If the models are predicting well, we repeat in a circle that I call it hour 230. If the error exceeds the threshold, then we try to revise the input data and start from scratch. In this graphical summary, I summarized the general idea about data science. The theories are extracted by pure sciences, and we could have some methodologies, that is combination with the dynamic of data and the problem will give us algorithms. Programmers make some applications with these algorithms and deploy the models as a service. In all these last steps, the domain knowledge and domain language should be considered to make a user-friendly and understandable final product for the risk managers and financial experts. For finance, the graph shows more details. First, we have methodologies and theories. Then, with the help of data engineers with high quality data, we extract some strategies. The backtesting and graduation make a reasonable product from data science to solve the problems of finance and risk management. As you can see, many soft skills, underlying knowledge, and support teams are involved in this complex process. For teaching this complex process, we need to combine and take advantage of problem-based learning, flipped classroom, role play, case studies, blended learning, and learning by doing, which seems to be difficult to combine all of this, but might be possible with a good timing and free online solutions and technologies. For the first part, which is related to pure concepts of mathematics, statistics, computer science, and finance, I designed a flipped classroom and used the role-play method by combining theoretical classes with some activities on our class YouTube channel and LinkedIn group to develop not only the pure knowledge but also the soft skills of students, such as presenting and justifying their ideas and solutions. The YouTube channel gives the student this opportunity to present the chapters of the reference book and comment on the presentation of their colleagues. It helps a student to develop their knowledge and their presentation skill. The channel is not only focused on the presentation of students but also includes some short videos from me as a teacher as support materials. Briefly, the theme of this activity is providing a platform for a book club, presenting the book, and being familiar with many good educational resources, of course, about data science on YouTube as a quick complementary reference for data science topics. As you can see by now, two books are presented. One book is about data mining and predictive analytics, and the other book is about financial machine learning. The other platform is a discussion group about data science in business and finance. The discussion group is on LinkedIn, which is free with nice features for this activity. Students with their profile could have good networking and could ask their questions to right people, and it made them motivated to participate in discussion. So the group was successful to make an active learning atmosphere by discussing a lot of new challenges in all parts of that graphical summary of financial data science. For instance, in this topic, which is data science for finance, we had 250 comments, QAs, and discussions among the students. Coherent, meaningful, and professional comments from students, which gives everybody chance to distribute their personal knowledge. And it is important when you have different students with different backgrounds, right? And they could learn from each other and empower themselves for understanding complex problems of finance through data science approaches. I also, as the teacher, provide them some short articles about the new modeling approaches or recent ideas about financial analytics. And they have this opportunity to share their ideas or even correct me if they know better about that recent revolution or event in financial markets or financial data science. The second and third parts of the skills and knowledge are about data engineering and providing algorithms based on methodologies. To cover these two parts, I use the free platform of CodeOcean, and I put a complete machine learning program in PySpark from online credit scoring, including the real data, codes, and results. So you can see a complete platform with computation power to publish your educational code, which is completely reproducible. This credit scoring and credit risk management program starts with feature engineering. Then you can see elastic net regression, the lasso regression, ridge regression, random forest classifier, and finally the linear support vector machine, which is not only a help for students to see a real example of solving a problem of risk by data science, but also to help them in their projects with a PySpark code, which is based on Python and also Spark for big data. Then we have parts 4, 5, and 6, which are deploying the program and automation. What I did was I defined a group project to solve a financial problem with modeling, and I use Kaggle for blended learning with a hybrid teaching approach. So the Kaggle is a subsidiary of Google, as we know, an online community for data scientists and machine learning practitioners, and all facilities are free for professors. It provides an environment to teach Python, R, data science, machine learning, and gives the students an equal platform without the need to set up anything on your personal computers and completely online. With free but of course limited computational power, even you have GPU, which is enough for learning purposes. Students could publish their codes as different versions, and the teacher could follow how they are going. Making a profile is very easy, and it has very user-friendly environment with possibility to define competition for educational purposes. You can share data, even big data in large volume. You can share codes, which might be a troubleshooting for a student, but others could also benefit. And also you have this opportunity to make a discussion group for troubleshooting and QAs, which is accessible to everyone who has your permission, of course. It is one of the best places to define and manage the group projects of students. They can upload, download the data in any volume, even big data, as you can see in this slide. They can benefit from the same programming platform with free computational power. The discussion part gives them the opportunity for troubleshooting and QAs. As you can see here, for one project we had around 100 questions and answers. This is also good repository for students in future. And they learn how to help each other as data science and data scientists, because data science is teamwork and being generous to others. They can see how their models would be evaluated with an unseen and new data set as the test data set. And they can upload their solutions several times, and the platform would give us a score automatically each time, so they can revise the models if the score is not good enough and try again. So the model that was developed first was studied for data science for official statistics, and was published in one of the official statistics journals, which are available in the last slide in the references. And from last year I started to work on the model to develop it for data science in finance, which is completely different topic with of course different characteristics. According to the Teaching and Learning Evaluation Questionnaire, the course evaluation shows an average of over 4.5 from 5, and all individual questions higher than 4. Also, it provides us a rich repository of knowledge on different platforms, usable for everyone, not only our students. Using free, accessible, and online platforms makes equal opportunity and tools for all students with maybe different personal resources and facilities. It also allows the students to empower not only their hard skills but their soft skills, which is critical for applying data science to complex financial problems. A shortcoming of this approach was the required time to review and supervise all these platforms and activities of students by teacher. Finally, these are some selected references. If you have any question, I'm happy to answer. Thank you for listening.
Thank you very much, Afshin.